Hello, my name is Gayatri Valmikai and our topic is compare transient response and steady state response, separation and analysis of transient term and steady state term. Next, I will explain the introduction of our topic. In control system, when an input signal is applied when is a input signal is applied, the output does not reach as a final value immediately but changes gradually with the time. The responses have two types: steady state response and transient response. This overall behavior of the output is called as system response, which is divided into two parts: transient response and steady state response. The transient response represent the initial behavior of the system just after the input applied, during which the output may rise, oscillate, or overshoot before settings. This part exists only for a short duration and depends on the system dynamics. After some time, the transient effect disappear and the system reaches a stable condition where the output becomes constant. This is known as a steady state response. The steady state response indicates the final value of the system and reflects its accuracy. Thus, the transient response show how the system reaches the final value, while the steady state response show the final stable behavior of the system. Thank you.
My name is Mansi Argadin. I explained the whole simulation diagram of comparative analysis between transient response and steady state response. This is the first block. It is a step input block, and this block provides a step signal as an input to the system. And a step input is commonly used because it clearly shows the both transient and steady state behavior. And this is the transfer function block. This represents the mathematical model of the system, and it defines the relationship between input and output in the Laplace domain. And the output of this block is system response, and this is the scope where the transient response is shown, and it directly connected to the transfer function output, and it displays the complete response including transient part and steady state part. And this is the summation block, which performs the subtraction output signal minus scale signal, and result gives error signal. And this helps is analyzing how far the system is from desired behavior. And this is the gain block, which multiplies the signal by 0.5, and this represents the scale reference or a feedback signal. And this is the block which displays the error signal, and this error changes large initially means transient, and small or constant later, then it's called steady state. This is the whole information for the simulation blocks available in the transient response between steady state response. Thank you.
Hello, my name is Ankita Mazgar. I will now explain both scope output. The first scope shows the system response, and the second scope shows the error signal. Using this, we can understand the transient and steady state behavior of the system. First scope shows the output graph. This graph shows the system output response. The output starts from zero and increases gradually. In the beginning, the response is changing, which is transient response. After some time, the curve becomes constant at 0.5, which is steady state response. The curve is smooth with no oscillation, so system is stable. And other scope shows the error graph. This graph shows the error signal. The error signal near zero and decreases gradually. Initially, the error changes rapidly, which indicates transient behavior. After some time, it becomes constant near minus 0.5, which is steady state error. This shows the system reaches a stable condition. Conclusion. The conclusion of this simulation, the system shows both transient and steady state behavior clearly. At the beginning, the output changes quickly, which is the transient response. After some time, it becomes constant, which is steady state response. The error also becomes constant, showing the system is stable. Thus, the system moves from transient state to steady state smoothly. Thank you.